I know many of you, I'm a card-carrying fan of GAI Insights, the morning meeting, and then a lot of other insights that you're providing to the community. I have a bit of a cold that I'm getting over, so excuse me. I'm VP of Research at Eckerson Group. We're a boutique research and consulting firm focused exclusively on data analytics. I've been doing a fair amount of research on generative AI, and in particular, the intersection of generative AI with data management and data governance and ways they help each other. It's kind of a yin-yang relationship. Vector databases, as Paul said, are an integral part of data environments that are helping enterprises get more serious about generative AI. The survey data that we're doing, we've seen from others, including Randy Bean at Wavestone, another partner of ours, is indicating that a lot of folks are experimenting with Gen AI. Some are moving into production. It's more limited production right now, but there's a lot of investment that continues to increase. So that's why we're all here. Let me share my screen and we can go from there. Okay, can folks see my screen here? We've got a slideshow mode. Are we good?
We can see.
Okay, great. All right, vector databases have gone from sort of niche specialist to rockstar status pretty quickly, riding on the coattails of generative AI. Vector databases have been around for some time, and I'll explain why they're starting to matter now. Just to frame things a little bit, I'll show a chart that's probably similar to something I might have shared in an earlier discussion here to level set the conversation. I believe we're in a vigorous part of phase 3 here. The phases do overlap. They don't necessarily go in the sequence with enterprises, but point being that the starter gun fired November 2022. A lot of thought workers, knowledge workers, and consumers started using ChatGPT and so forth. Google Bard, it's obviously Gemini now, in order to improve their productivity. So that's stage 1, still happening. Not overly governed in a lot of organizations. Then you've got these language model assistants within tools, Salesforce, Einstein, GitHub, Copilot, and so forth. We're just finishing up a survey report on Gen AI assistants that are within business intelligence tools. A lot of uptake there, pretty interesting stuff. But where things get, I think, particularly interesting from a strategic perspective is where you get into stage 3, language model-driven workflows. Companies building language model functions. Maybe it's derived from OpenAI or GPT. Maybe it's derived from some open source models out there. They're building these functions into proprietary workflows. So they're starting to stitch together custom tools, applications, and really start to take action on some of the insights that come out. The interesting trend here is that there's a movement, the parameter counts that are required, as we know, are going down. Some of the recent parameter counts that are coming out are certainly much lower, orders of magnitude lower than the reported 1 trillion parameters for GPT-4. And there's also an increasing focus on domain-specific data. Given these trends, we're using more and more the term small language models. Microsoft, among others, uses that term mostly to refer to lower parameter counts. But in my view, I think small language models are kind of the heart of stage 3 here, which is that companies, they might take a pre-trained large language model, ChatGPT, but then start to fine-tune it or prompt it with their own small domain-specific data sets. That's where things get interesting. The survey numbers I have here are actually outdated by a few months, so I suspect it's a lot higher. But a lot of these companies are starting to experiment with, and some going to production, domain-specific LM-driven workflows. And so I won't go into too much detail here, but there are 3 options. I think we all probably know these to get serious about small language models, about domain-specific, enterprise data-specific language models. You can build something from scratch. Not a good idea for the vast number of organizations, in my view, and I think most folks. It's a lot of work. It's hard. That's why OpenAI is valued at what it's valued at. A lot of companies are starting to look at fine-tuning existing LMs. And this is where you're starting to change the weights and biases. You're starting to change the parameters within an attention network that reflects different entities. And that's in order to adapt to specialized ways in which your community of people uses language, or specialized ways in which it uses images. So a lot of companies do that. It does get expensive. And then I think much more common is RAG, enrichment of language model prompts. RAG is becoming, I think, kind of a must-have aspect of these initiatives, because that's where you're pulling up relevant information from your domain-specific data. Hopefully it's governed inputs. You're using that to effectively give an open book test to the language model. Excuse me, key point here is that vector databases can play a role in all three architectural approaches, most commonly with RAG, but it can help you fine-tune an existing model because it's going to perform semantic searches and pull up the right tailored information and reflect how these different documents or chunks of content relate to each other. Okay, so that's some context here. I think the key point about why you need a vector database is that if you look at fundamentally what generative AI is, relational models just don't work. We're not talking about rows and columns here. You're starting with tokens, and this example is for text. You could start with a declaration of independence. You've got tokens, which are essentially individual words or punctuation marks and so forth. You're going to divide a body of content into chunks, and then parameters, which are numbers that measure the relationships of chunks and tokens. These become parameters or vectors within a vector database, and you've got an attention network that uses parameters to essentially show statistically how all these chunks and tokens relate to one another and what they mean. So you can picture a vast set of content, and you've essentially created a massive number calculator that's going to reflect how all these things work together. And it's high dimension data. You've got one data point. In the case of the Declaration of Independence, you might have the preamble. A lot of parameters or attributes of that content, and now you've converted it to numbers to show how it relates to lots of other things. And so the one data point would be the preamble and the Declaration of Independence, and then it's going to have a lot of features about what it means and why it matters. And that's why you can't simply have a table to reflect this information. You know, high dimension data, one data point, lots of dimensions or features. So language models are trained on high dimension data like this in order to generate, we hope, accurate responses. I'm going through a lot quickly in order to get to the vector database part. I'll welcome contributions or questions as we go. I know I'm dealing with a sophisticated audience here that probably understands a lot of this too.
Kevin, you're doing great. Keep going.
All right, okay. All right, so vector databases. Enter the vector database. Vector databases store, organize, and then maintain and deliver high dimension data. So it's going to store all these vectors. It's going to store metadata associated with those vectors, which is critical. You want to make sure that your text files, you understand the lineage of them, you understand their meaning, their context, and vectors might not capture all this. You need additional metadata. So you're going to put all this in an object store. It's probably going to rely on S3, Google Cloud, and so forth. And then you need to organize these vectors in the metadata. You're going to create indexes that are going to put vectors alongside one another based on how similar they are. So when in the course of human events is pretty similar to other nearby parts of the Declaration of Independence, they'll probably be close to each other in the index to facilitate a similarity search. You're also going to have the ability to govern access and usage, similar to a way another database would, which is role-based access controls, encryption, things like that. So you've organized your vectors, the metadata, you've indexed it, and now you need to maintain it. This is where you get to similar features or capabilities that exist for other types of databases: inserts, updates, deletes, similar to with a relational database. When source data changes, you want to reflect that and have that synchronized and mirrored to what's in the vector database. You also want to support, and this is kind of the heart of it, the semantic search, where you're going to be able to pull up chunks of text or full documents based on a check of vectors that are similar to what was requested. And so that becomes really important for retrieval augmented generation as an example of supporting generative AI applications. So these are kind of the fundamental capabilities of a vector database. There are a lot of companies that are coming out with this and are pretty hot stuff on the market. Chroma, Pinecone, we hear about a lot. They've got a lot of the early mind share among pure plays. Weaviate is doing pretty well as well. And then there are suite players that are broad-based data platforms. Databricks made announcements in this space. Not sure how robust what they have is yet. There's other companies too. Some of the big ones here would be MongoDB and DataStax. And I think that if you kind of look at the balance of pure plays and suites, there are definitely some specialized capabilities with vector databases that you do need that specialized intelligence about how chunks relate to each other and the ability to capture that. But at the end of the day, in my view, this is kind of going to become a feature, a must-have feature of larger platforms. And Databricks, given all it's doing in other areas, would be an example of a company that has a longer-term advantage. So there's kind of a debate right now in the industry about pure play versus suite. We did a survey on LinkedIn, and I think I had 40 responses or so. Not a great sample size, but 59% said they believe that vector databases should be part of a suite. And it was a little less than 20% that said it should be pure play. Now, the rest was kind of in between, or both have value. So that's kind of where we see things heading. And it's a consideration, I think, for companies as they're trying to figure out the lowest risk way to invest in this industry and the best way they could make sure that they have reliable platforms in the future and don't get stranded. With that said, Pinecone and Chroma are doing great, and these others, they'll probably get acquired, in my view. Okay, so no big surprises here, but there are pros and cons to doing this. Essentially, the pros of a vector database, in my view, is that you're making Gen AI successful. And the big benefits of Gen AI are productivity, improving knowledge worker productivity, improving efficiency of processes. Maybe it's customer service, maybe it's document processing or assisting RPA or all sorts of things, as we know. Software development is critical. You're also enriching digital interactions, especially with customers. And so that's another big benefit. And when you get to that third phase of going more domain specific with fine-tuned or prompted language models, that's where competitive advantage can happen. So I think a vector database can make this happen if they're managed carefully. The obvious challenges are that you've got some training. The vector database companies will tell you, not without reason, that you could have a DevOps or software engineer pretty quickly spin up a managed service on Weaviate or some of these others. And that's true, but in the end of the day, you do need people that understand the fundamentals of how vectors relate to each other and understand how to handle that. So there is some training. There's potentially complex data preparation. If you're taking a text file and you're trying to make it become vectors that are appropriately stored and organized in a vector database, that takes some intelligence. And in all likelihood, it'll take a new type of specialized data pipeline tool. Unstructured.io, Datavolo, which is a client of ours, full disclosure, and some other companies are some of the ones that are playing in that space, helping prepare and then load and ingest data into these vector databases. And of course, governance is absolutely critical. I'm a big proponent of the fact that so many companies just aren't ready. They don't have quality controls in place, governance controls in place to support AI, especially generative AI. So that's a big challenge for all of this. And a lot of that gets to having the right metadata and the right confidence that the vectors and the organization of the vectors really reflects ground truth for your data.
Kevin, there's a couple questions. You want to take questions now at the end?
Sure, we can go now. That's great.
Go ahead, Lucinda. Thank you for raising your hand.
Yeah, thanks. Hi.
Hi, Lucinda.
Kevin, great presentation intro. So one of the things that we have this debate all the time at Ironside where I work is, okay, vector databases, they have to do this very sophisticated indexing and kind of even double indexing sometimes, plus all the syncing, plus measuring geometric distances on, dimensions that are 1,000, wide. So
Yeah.
how can you just paint a vector database and make it actually do that? What's the process and how hard is that? Because I just think about, like, it's so different from what vector databases do. Yeah, I understand what you're saying about the data processing and the syncing and all that stuff too. But like, it just seems like such a very different operation than what relational databases do. How can a relational database, like, what does somebody have to do, like Oracle, to a relational database to make it even do the things that a vector database can do and maintain the relevancy? Because large language models are so picky and so, like, one little word can change the outcome. And this is a very insidious thing to way that you are pulling your chunks and ranking them. Like, how can a non-vector database do that?
Okay, so great question. I think that in most cases, what's really happening is that when a relational database platform says we can support vectors, it's kind of as a standalone initiative where it wouldn't really be part of the relational model. There are some companies that are trying to merge those, but it really is a distinct domain and a distinct set of features. And the classic engineer answer, and I'm actually not an engineer, but it depends about how to do this right. There are different techniques with chunking. For example, when you create chunks, it's better to have them overlap a little because then you don't accidentally reduce any context for a chunk by truncating a word or a paragraph. So there are things like that that can improve the integrity of what you load into the vector database. I think there is some tuning involved, and a lot of that gets to starting to look at the accuracy of responses. For example, with RAG or with fine tuning, where based on what you see there, you'll want to start to change the weights of the parameters in order to improve accuracy. But yes, it is a different domain, and the reason I'm giving more advantage, sort of home court advantage, to more traditional platforms. And I'm using Databricks as traditional, which is probably a little myopic, but they just have incredible resources to throw at this. And they have incredible already data science expertise. They purchased Mosaic. And so it's less a question of exactly how they could adapt their existing platform to support it than the resources and the smart people they could throw at the problem, because it is a different domain, to your point.
Yeah,
I'm not sure I answered that, but it's
like, okay, thank you for the explanation. I do feel like it's a totally different playing field. So it's
yes.
like, okay, I'm really good at ballet. Now put me out on a football field, so.
Yeah, well, so one of the points that I'll make as we go through this is that I believe Gen AI is not an initiative. It's getting all kinds of standalone attention, but ultimately it's a feature of next generation applications and workflows. In all likelihood, and Databricks agreed with me this last week on a vendor briefing, ultimately you want this alongside Rusty SQL queries, alongside a graph database, alongside predictive ML.
You definitely want them to all work together. Yeah, definitely.
And it helps if all the supporting data is in part of the same platform.
Yep. Okay, thank you.
Thank you, Lucinda. Go ahead, Tim.
Hi, so I may be over my depth here, but in fact, I don't think they're at all different playing fields, because if I remember my math well,
No, please go ahead.
If I remember my math well, and my original work in deep learning, actually deep learning is all about sparse matrices and high dimensional embeddings. So it's exactly the same math. The difference with large language models is that they have decoders, not just encoders. So the deep learning models have encoders, but they don't have decoders, so they can't generate anything. But deep learning has long trained with unsupervised learning, and I believe it uses complex embeddings very similar to those used in large language models. So that part is pretty similar. But ultimately, I agree with you, Kevin. The big advantage that the Databricks people have is their brand power and their resources. Just have so many customers and so much expertise and so much capital that they can just buy all these other people.
Yeah, that's fair. And so, Tim, I should probably qualify my statements a little bit. I was thinking that the relational model is different from this, but I agree that if you look at what
okay, yeah, if we're comparing
Gen AI is doing, it's
relational,
essentially
that's a different kettle of
natural language
fish.
processing a little further.
Yeah, good point. Good point.
Okay. Yeah, no, great comments.
Alan had an interesting comment online on chat. Alan, do you want to share that? Maybe Alan left. Alan's, I'll at least represent Alan.
Okay.
Mike,
You're sorry, putting me on the spot and I didn't have my camera prepared. Yeah.
go ahead, Alan.
I assume this was my response to what Lucinda was saying. And I think some of that is that, if we look at what a lot of these vector databases are doing right now, is they're just kind of saying, you hand us a chunk and a vector, and we're not going to do any of the work for you. We're not going to chunk it up for you. We're not going to figure out what optimal chunks and optimal overlaps are and so forth. You give us an identifier, you give us a vector, and we'll do the magic of finding similar ones. But it's kind of up to you to do that higher level work. And we are seeing more and more systems that are coming out that are saying, we'll do that chunking for you, we'll do that higher level work, we'll do all of that, but it's our secret sauce. We're not going to tell you how we're doing that, or give you all that much control over how we're doing that. So the databases themselves are doing just the low level stuff. And that's pretty easy to integrate with relational databases, because that turns into, it's just another index. So
Some great points there.
Yeah, I think I was agreeing with much of what you're saying.
Okay, yeah, I think you're right. So and that would point to some of the data pipeline. So the startups that I mentioned, and there are others too, like Unstructured Data.io, Databolo. There's some others that are coming to mind right now that are starting to provide that that intelligence about how to handle chunks responsibly. We're going to do that. Definitely.
Kevin, the other thought that Alan had was that these should be called vector indexes and not vector databases. Do you agree with that comment?
So I would say that indexing is a critical feature. So vector search or semantic search and vector indexing is critical. There are other aspects of a database that need to be supported as well. The storage, the handling of metadata, the governance, as an example. And that's so that when you wrap all that together, I would say it's a database. But yeah, there are definitely standalone sort of vector index tools.
I would agree with that. I think just what most people are seeing when they look at some of these tools, like Pinecone, like many of the others, is that they're not doing so much of the storage part.
Yes, correct.
Many of them will do we'll take the data and give you back a reference number to it, but they're not going to store that chunk for you themselves. But you make an excellent point about how a lot of the other metadata that's associated with it, the permissioning, the access control, all of that, that's a fantastic point that I don't think I was considering the same way. So thank you.
Okay. Yeah, no, that's exactly right. It would sort of layer on top of a cloud native object store in all likelihood.
We'll do a few more questions. Go ahead, Alden.
Great.
So one of the things that Pinecone also does is the ranking, right, of the chunks when you do a search. And
Yes.
right now it's quite primitive, but over time, I would expect them to get better and better at the rank algorithm when you search, right? And also the more advanced stuff like the hybrid search. So they will do stuff that will give them a competitive edge compared to just like, Postgres vectors or Redis vectors or somebody like that, because they are doing that for a living. And we've been using Pinecone from day one, and it's been like a godsend because literally we had to spend like an hour dealing with anything to do with vectors.
Okay.
And
Yeah.
more on the RAG pipeline and value add that we do on top of it.
Yeah, Pinecone's done some great work, and they've also, I think, done some good research about just how far you can get in terms of accuracy, plus a standard off-the-shelf LLM if you use RAG. So in any time I talk to one of those pipeline startups, Pinecone is the first partner that they talk about. So they've done some great work.
Yeah.
Definitely.
Great. How about one more question for Kevin? Kevin, while we're waiting for stuff, what's your view or
Yeah.
anybody else's view on source of truth with data that's being updated all the time? Is it just the reality that you've got to keep? What are approaches sense for that?
It's hard to do. And so that's where, you know, we've got the, where is it here? DML. So the ability to insert, update, delete. And it's easier to do with a relational database than a vector database. But yeah, if you can have those continuous or near real-time updates from sources to reflect the reality, all the better. And I think the benefit of RAG is that you don't need to have this multi-month period of going out and retraining stuff and say, okay, this is current as of 3 months ago. Rather, if you keep your own database, your own vector database current with the very latest product manual, the very latest customer service records, whatever it is of your own domain-specific data, then you can be confident you're going to inject that into the prompt and thereby keep things current.
That's great. Thank you. We'll go last question, Lucinda, then we'll go to open.
Hey, you guys, just for what it's worth, the lead investor in Pinecone is a very good friend of mine. So if anyone
good.
wants to ask about, I don't know, just any new products or just the behind the scenes, I'm happy to help broker that. This is John Warner.
Thanks,
Excellent.
John. Thank you, John. Go ahead, Lucinda, and then we'll go to
Yeah,
open.
just a little bit of following up on all this. So Alden mentioned the ranking, but it's also about the retrieval as well. Like how effectively does it retrieve? I mean, all these things kind of are, if you think about like errors compounding upon each other, 0.97 times 0.97 times 0.97. I'm just not seeing how relational databases as a structure can be able to do that. In terms of the players, yes, maybe they'll just acquire a Pinecone or Weaviate and put it in there. Totally agree with you on that. I'm just saying like slapping a PG vector on top of a relational database, I don't think is gonna yield the same results. And it's a very, very, very sensitive process, how language gets processed through vector databases, ranking, retrieval, LLMs, etc.
Yeah.
So I just want
Okay,
your reaction
that's
to
fair.
that.
No, I tend to agree. I think the comments that I have about the value of the suite is more based on resources, installed base, and expertise to do the hard work of development.
It's a different animal. Okay, I rest. I rest.
Thank you, Lucinda. Tim's got one other comment, then we'll go open.
Yeah,
Go ahead.
I'll be quick and I'll try and be more following the right conversation this time. So apologize.
No, that's right.
But I agree with Lucinda. This is an important point. People are doing okay with these vector databases, so we'll see where it goes. But you have two problems. You have the selectivity and the sensitivity problem, right? Beyond, and that's assuming your data is vectorized right in the first place and you've got the right data in there. If you have too many results, it will bog down the query. If you don't have enough results, you won't get the right coordinated data. So there is some art to this, I believe, at the moment. So we'll see where it goes, because I have seen people struggle a little bit with that problem, that either you have to decide how much of the result you're going to take, like how similar is similar enough that I'm going to send it off to the large language model to retrieve. And Alden probably has more experience than all of us at this, but my experience anecdotally is it's tricky.
Thank you, Tim. Go ahead, Alden.
Yeah. So the vector database job is not to solve all the problems. Their job is to just give you back the chunks, and then you get to decide how much or how little of them you use in the LLM call. And that's what we do. We ask for 100, and then we keep adding 1, 2, 3, 4 till we reach the number that we want. And that's part of the secret sauce of like the chunk re-ranking. But that's our application. Each person will have a different application needs on that.
I have a bias, which is that I come from more of the traditional data management background. And I think that a lot of this boils down to making sure you put the right curated subset of your data that you can trust into this process. Because you can only do so well with vectors that ultimately represent data that's duplicative or inconsistent or things like that. And so a lot of this gets to fundamental data management best practices and metadata management and metadata governance, and applying what you've been doing with tables for a while and now applying it to text files, because that can reduce the risk once it gets into the vector database.
That's great. Go, Bob, if you're quick, go ahead, Bob.
Kevin, it sounds like you got a sales pitch from the Databricks guys. Here's a simple question for you.
Oh. They're not they're not a client of mine. How's that?
Well, if you want to level if you want to determine who can do what, this is a heavily discussed topic in the data science community. You know, dedicated vector databases versus a field in a relation. Ask them if they can do 1 trillion dimensions. You know, 1 million vectors with 1,000 dimensions each, and ask them if they've gone up to 25 to 50 trillion dimensions in their vector search.
Okay, I'm going to write that down.
Separate out an add-on function capability from folks that can truly store and search really, really large, high fidelity data.
So Bob, who would make a short list of folks that can do that?
Pinecone. So I met with Ido Liberty, who's the CEO there. So we had a side discussion. I particularly wanted to understand. Let me stop my discussion as opposed to going down a rabbit hole. But as he gave his pitch, which was sponsored by the seed investor, Wing AI was the seed investor there. I know the partner there that runs the firm. I had a chance to talk to Ido afterwards about a bunch of stuff, and during his talk and subsequently basically said, if you remember the old Indiana Jones saying, that's not a knife, this is a knife kind of thing. It's just a whole nother range, right?
Yeah.
So let me just conclude with a simple analogy. It's almost like whether you use an AI first approach, you know, a large language model, or you're a Google, Microsoft user and you're using AI within an existing application. Which one's better, right? So each of them have their advantages. I think the same analogy can work here. That's the way I read it.
Great.
Okay.
Well, thank you. Kevin, thank you so much. Great presentation. So thank you for that. And we appreciate you coming back. Let's just take 5 minutes for open mic. Open mic is someone raise your hand if you want to share something, ask any kind of questions to the group. Last week, we showed a little bit of Gemini that's now embedded into Google Workspace. We're starting to use that at my end, at our company. It's not getting my fingers moved away from ChatGPT, but who else has something they are blown away with or something they're excited about? Or go ahead, Daniel. Thank you for raising your hand.
Yeah, absolutely. You said just to pose a thing to the group. I'm a UX designer. I'm curious, especially given like the prominence of people that you're having conversations with, like where's the play in the UX? Like, is it even a consideration anymore? Or are people just like, oh, AI's got a problem solved? Or is like, you know, is it still in there somewhere? Guidance would be
Does matter
appreciated.
anymore? I think that's the question. Does anyone have a view on that? UX dead?
I can take a stab on that. This is
Go ahead.
Angela. I work on HubSpot AI product team. I feel like UX is not dead at all. UX is actually super important to guide people's decision on like what they are looking at with AI generated experience. Because what's tricky about AI generated experience is that it's not deterministic. I think there's a huge role for UX to play to make sure people understand when model doesn't always provide the same outcome as they're expecting, what exactly they're looking at. I think there's a huge role for UX to play to train people how to interact with AI Copilot and be able to iterate the AI outcome in order to get to where they need to be. So I would love to see more UX perspective around AI experience. I think we're all building that and learning what works best for human interaction.
Angela, great response. Anyone else on the UX side?
Yeah,
Daniel,
on the UX side, not just the generation, but you can also use ChatGPT and GPT to optimize the UX. So a lot of work is going on that side as well. You can literally take your page, put it up into ChatGPT, and do a UX analysis on it. So
And if you haven't seen, what was the demo we saw a couple of weeks ago? Galileo AI, which was
yeah,
doing, that's unbelievable for mockups. So the UX people haven't seen that yet. Go take a look at that. Go ahead, Alex. Alex, you got the mic. All right, we'll work on
Yeah,
Alex.
sorry about that.
ahead.
Yeah, I was just gonna not really answer about the UX. I just had a comment. I think it was really telling that there was a report that came out that ChatGPT uses around 17,000, or I'm sorry, 17,000 average U.S. households daily electricity. And there was also an interview with Elon where he mentioned that there's going to be an energy crisis looming from the AI compute. And I think that a lot of people should start looking more into that, because that's going to be the thing that happens a year or two down the line because of these things. Because Amazon is also buying a data center within Arizona, and you could kind of see the pieces are kind of falling as they are. There's going to be a looming electricity crisis, and what the bigger AI community / science community can do to kind of prevent that.
It's a great comment, Alex. Thank you. Let's have a few more. We'll do just two more. Alan and Raymond. Go ahead, Alan. Then we'll finish up.
Quickly on the UX issue, I want to point out that conversation design is a huge user interface, user experience topic that's been talked about for 5-10 years now even, but it's really coming to the forefront when we talk about how to integrate conversation design with prompt design and prompt engineering, and what are these conversations looking and sounding like when we have the models talking to people. So it's becoming even more and more important these days. So that's certainly an angle of UX to look into.
Thank you, Alan. Fantastic. Raymond, take us home. Last, Mike, you got it.
Oh, hi everyone. Yeah, I did some work maybe 5 years ago, 6 years ago with, the what was it, Amazon Alexa, and you had to deal with the intents and expect responses that you didn't expect, like how to handle questions that you didn't expect. So someone mentioned language models giving unpredictable responses. I'm hoping that we can come up with a way to associate with these LLMs the same way we do with humans. Like when I speak to my wife, I don't use a keyboard or a mouse, right? When I speak to my son, I don't have to go through something. I just talk to him face to face, have a conversation. And so I think that like these websites I think websites are going to be a thing of the past. I think it's going to be LLM first. And I think there's also going to be, I said this a while ago, pocketbook LLMs where everybody's got their own, and you can essentially, it won't even be, it'd probably be closer to that Rabbit thing that I saw, that came out about a month ago. They were talking about, that device where it's just the OS and no more apps. I don't think websites are going to be a thing anymore. I think we need to talk to each other as humans, and I think the LLMs are going to expect that.
Raymond, fantastic comment and contribution and way to end the meeting. So thanks, everyone. Let's keep the ball rolling, and we'll talk many of you next week.